Thanks, Marie. So as Marie said, I'm Stephen McGee from the Learning Partnership, and I'm a learning scientist. And this paper was written with my colleagues, Ron Greenberg, Lucia DeTore, and Dale Reed, who are all computer scientists at local universities in Chicago. And they're the ones that have been supporting the effort to bring exploring computer science to Chicago, and my role was to study that implementation. And so David stole some of the thunder, but he had shared the big news in Chicago is that they actually passed a resolution to make computer science a high school graduation requirement just this past February. I was actually at the board meeting where they were discussing it, and one of the teachers was presenting, and when he was finished, the chair of the board said, "You're preaching to the choir." And so it was a unanimous decision to pass that. I do have some bonus data for you to share that just recently got this data from CPS. So looking at some of the growth of computer science in Chicago prior to and led up to their ability to pass the resolution. So this is showing the number of schools that are offering computer science, any type of computer science course at their school, not just ECS. The red dot represents sort of baseline data, which was before the Taste of Computing project actually came to Chicago, which I'm going to be talking about. So it's about a 25% increase over that time period of the number of schools offering computer science. It only represents about 40% of the high schools in Chicago. There's more that have actually joined this year, but I think that they're up to about 50% of the schools. So there's still quite a ways to go over the next 4 years to get all schools to be able to offer at least one computer science course. But what's interesting is that there was actually a much larger growth in the number of students taking computer science during that time period. So it's about a 50% increase during that same time period in the number of students that were taking any kind of computer science class. The dot, I realized I left off a one, so the 12-13 school year is the year that the Taste of Computing project started, and this particular presentation is going to focus on the second year of the study, the 13-14 year, which is why there's a bigger dot there. So the project we're talking about today is called Taste of Computing. It's a play off of the festival in Chicago called Taste of Chicago, which is where you get a chance to eat all different kinds of food in Chicago. So the idea with the Exploring Computer Science curriculum is a taste of different aspects of computer science. The program was co-developed by Joanna Good, who's with us here today in the audience, as well as Gail Chapman. And it was brought to Chicago and was one of the first places to actually move out of the Los Angeles area and bring ECS to a different urban school district. The focus of Exploring Computer Science, so it goes beyond what David had mentioned in terms of block-based programming. So that's one of 6 chapters is focused on programming. And the core fundamental is to shift the way computer science is taught to focus on equity as a primary pillar, and upon that is built inquiry and then computer science concepts. And so some of the ideas around how equity is built is building on the cultural resources of the students, or what Louise Moll would call funds of knowledge, real-world problems in computer science, as well as helping teachers develop a culture of inclusiveness and caring. And inquiry is about having students develop their own questions, their own problems, and engaging in collaborative inquiry to deepen their knowledge. And then all of that serves as a foundation for rigorous development of computer science concepts. And just to give you an example of how those three sort of meld together, this is an example from the second chapter in the course on problem solving. It uses the idea of a cultural style, a cultural hairstyle in the African American community, so it brings in sort of cultural knowledge, but then layers on geometric mathematics ideas for how those hairstyles actually can be described. And then using inquiry, kids can explore different ways of mathematical principles to create different kinds of hairstyles through mathematic principles. And then this map also shows the spread of the Exploring Computer Science program as of, I think, 2 years ago. And it continues to grow with support from the National Science Foundation, as well as Code.org is providing some support to help spread the program. As I mentioned, Chicago was one of the first places to adopt the Exploring Computer Science program. And one of the things that's wrapped around the program is not just computer science, and Joanne and her colleagues have written a lot of papers describing the whole profession development process. But it involves a one-week course or one-week workshop prior to teaching the program, 4 Saturdays throughout the year, and then the teachers actually come back for the same workshop the following year and integrated with new teachers that are preparing to teach the program. And what's interesting is this process actually pulls in from a variety of different disciplines. So it's not just computer scientists, computer science teachers learning how to teach this new approach, but it's bringing in science teachers, math teachers, English teachers, history teachers, business teachers, who are all able to then learn how to teach this approach of computer science. So our year 1 results, which we just recently came out in the Computing in Engineering and Science journal, we were able to show a link between kids' perception of the value of their course experience and that then influencing the extent to which they increase their interest in taking another computer science class in high school, as well as potentially majoring in computer science when they get to college. But because it was our first year and we were sort of getting up to speed and working with the Chicago Public Schools, we weren't in a position to actually do a pre-measure of interest as a covariate. Also, we were interested in sort of exploring in the second year some of the psychological constructs that might mediate the relationship between their course experience and their increased interest in computer science. So in our second year study, we then had our act together and we were able to actually include a pre-measure of their general interest in pursuing computer science as a major. And then we decided to focus in on this theory of expectancy value, which comes from Jacqueline Eccles. And the idea is expectancy is the extent to which I expect that I can do well in a particular discipline. And then value is the extent to which I value it both for myself, but also I value the discipline as something important for society. And there's decades of research to show that those constructs are actually highly predictive of selection of majors in college as well as career choices. And there's actually a study that we cite in the paper that also looked at that as a predictor for actually middle school choice of elective courses and kids actually going on to select computer science as a course. Okay, so our study sample, so it's in the second year, we're still sort of getting our feet wet and working in the district. So we had about, there was about 75 teachers that went through the profession development program. Most of them actually were very helpful in providing survey data and observational data that we were able to follow. We had about 700 students that filled out a pretest for us, but we only had about 154 students from 6 teachers where we managed to have the pre-measure, the post-measure, and the key thing was actually having parental permission. So this is a subset of the students that tended to be more of the teachers that were more helpful for us in collecting the data. Since that time, we've gotten a lot better and developed more partnerships with teachers to be able to collect more data. The nice thing is that the population is sort of representative, and this is representative of all of the teachers involved in ECS. It's about half girls, half boys. So that's nice that we're seeing more underrepresented groups going into computer science. And more than half identified either as African American or Hispanic. And for this population, it's a little bit lower than what we're seeing across ECS in general. So as I mentioned, we had a pre-measure where we asked students their general interest in potentially majoring in computer science up front on a scale of 1 to 4. And then on the post-survey, we then asked them as a function of this course, how much has your interest changed in majoring in computer science? From went down a lot to increased greatly. So we have sort of that negative to positive scale. And if we just looked at these two pre and post measures, which is sort of the null hypothesis, is there's the beta value is 0.56 relationship between these two constructs. So what we wanted to explore is what you might expect as well. The kids who are interested in computer science, they take a computer science class, they have more interest at the end. The kids that aren't interested in computer science going into it, might have low interest afterwards. And so what we were interested in seeing, is there anything about the course that sort of shifts that pattern in any way? And then what that would allow us to do is actually look at the mediation of the course and sort of shifting that basic pattern slightly differently. And so in fact, we did actually see a statistically significant mediation effect of the course. So if you look at the chart, the total effect row is what we saw in the first slide. There's a total effect of 0.56 relationship between the prior interest and their change in interest. And then if we now parcel that out between what's the effect of just the prior interest versus what's the effect of the course, most of it is still sort of based on their prior interest, sort of predicting the extent to which they're going to increase their interest after taking a computer science course. But about 1/4 of the effect actually is through the course, is mediated through the course itself. So the course is doing something that's changing that general pattern. The other thing that we notice in terms of the mediation is there's no longer a direct relationship between kids' perception of the course and whether or not they increase their interest. It's actually mediated through this expectancy value construct. So the the extent to which you saw value in the course increased your expectancy that I could do well in computer science, as well as the value that you saw of computer science as a field. So then just to show you a little bit of the descriptive statistics around how the shape of the change in interest. So about half the students at the beginning of the course had sort of a low interest in computer science, and about half had high interest. And so if you look across a row, what you'd expect to see is the low interest kids, about 2/3 of them either stayed the same or went down, but you have this about 1/3 of the students that broke that pattern. And so they actually somehow, as part of the course, increased their interest in computer science. But then on the high interest level, you actually had about 8% of the students that decreased their interest as a function of the course. And I think David gave some good examples early on of people who were sort of didn't really like the block-based programming, or were surprised, like they had a certain conception of what a computer science course should be like, and this wasn't quite what they were looking for. But that was a very small minority of students. So there's more details in the paper that talks about the constructs and the measures and some of the other descriptive statistics. But I did want to thank Brenda Wilkerson, who has been the real shepherd for getting computer science and the CS for All project in Chicago and actually getting the requirement in place. Don Yannick is one of the CPS computer science teachers who's also been very instrumental in bringing ECS to Chicago and is the president of the local Computer Science Teachers Association. Gail Chapman, who's been a co-author of the curriculum, but she's been very instrumental in developing a cadre of teachers who are now leading the professional development in Chicago, and of course, all of the ECS teachers and their students. Thank you. So I'll open up for questions.